In this video, we're going to look at transformations of functions. And we're going to start by looking at the function, the linear function 2x. 2x is simply the line we used to talk about as y equals 2x, although we are shifting into function. But I wanted to start with this because understanding how this line is shifted will help hopefully make it clear why the rules are what they are for function notation. So when we look at the line y equals 2x, you'll notice here at the center we have this green dot, and that is kind of our starting point for this line. It's at the origin. Now, if we wanted to shift this line, say, down to here, you may remember that when we are looking at lines, we looked at something called point-slope form, and point-slope form allowed us to write a line with a point and a slope. So we have the slope, it is 2x, but I want you to see that how we write things in point-slope form actually is a precursor, is kind of a initial showing of how we're going to talk about the shifts that take place in functions. So point-slope form is y minus y1 equals m times x minus x1. And the point, if you'll notice here, that green point, I kind of shifted it down. What I did was I shifted it, let's see, how many steps is that? It's 1, 2, 3, 4, 4 steps to the right. And then I shifted it 1, 2 steps down. So that's the point 4, -2. Now, if we write this in point-slope form, it has the same slope as the original, so that m is going to be 2, but y minus y1, -2, and then equals m, the slope 2, and then x minus the x value, which is 4. So the double negative cleans up to be y plus 2 equals 2 times x minus 4. But what I want you to see is this. When we talk about shifts, what we're actually doing is we're actually shifting that point that's at the origin. We're shifting it 4 steps to the right and 2 steps down. And when you look at this line of work, you'll notice that this tells us where we're going. If you look at this, y minus -2 and x minus 4, and I'm going to put this 4 in parentheses to emphasize that it's positive 4. But this literally means when we have x minus 4, that tells us that we're moving 4 steps to the right. And this -2, this -2 right here tells us that we're moving 2 steps down. So when we have y minus -2 and x minus 4, that is telling us that that starting point at the origin is shifting 4 steps to the right and 2 steps down. We can do similar things when we graph parabolas. And so I'm going to graph a parabola next because it'll help us illustrate this a little bit better in function notation, and we'll talk about why the function notation is what it is. Oops, not what I meant to do. So if I start at the origin in a similar fashion and draw out this parabola, this is the parabola that represents the function f of x equals x squared. Now, when we talk about shifts, you'll see, if you look at the textbook, that it talks about vertical, up and down, and horizontal shifts in a manner that looks like this. It'll say x minus h squared plus k, where h and k, that is where your vertex shifts to, where it shifts to. And so what I want you to see is this. If we were to make the same translation, the origin point, the green point, where if we shifted the same way that we shifted that line, so 4 steps to the right and 2 steps down, we would write that up to look like, let me finish, there and there. There we go. I've shifted this vertex, the starting point for this parabola, 2 steps down and 4 steps to the right. And we would write that as f of x equals x minus 4 squared plus, minus 2. Where h and k, similar to how we move that green point there, h and k is where the vertex is going to move to, the starting point is going to move to. It tells us that we're going 4 steps to the right, and in this case, the -2 tells us 2 steps down. Now, why is it that when we look up here, you have y minus y1, or if we're going to be consistent with this other thing, we'd say y minus h and x minus k. I did that backwards. If we're going to be consistent, why would we call this y minus k and this x minus h? And then down here, what you'll notice is it's no longer y minus k. The k is just over here on the right-hand side, and it's plus k. Up here it was minus k and minus h, and now it's minus h, but it's actually plus k. Well, the first part you got to notice is that the x minus h, that part is actually still consistent. We had x minus x1 or x minus h, and we still have that down here, and we look at shifts. Now, the reason it's plus k is because we're writing this in function notation. It's no longer y equals y plus or minus anything. Functions are written in a y equals form. We say this function is evaluated, so it's no longer y minus anything. It's just y equals. So how did we get the output of this function, f of x? Formally, we were talking about as y, but how did we get it in function notation? Well, we added the plus k. So originally, it would have been something like this. F of x f of x minus k, consistent with what we saw up there, equals m times x minus h squared, the parabola. But we want f of x to be alone by itself, so we simply add k to both sides. And you end up with this right here. F of x equals x minus h squared plus k. So similar to how it was with the lines, we look at those shifts, how it moves by minus the value that it's moving. So minus 4, x minus 4 means 4 steps right. If it had been x minus -3, say, it would be x plus 3 because that double negative there. But the k, the y change, the change in y value, the vertical shift will always be true to form. -2 does in fact mean 2 down. If it had been +2, it would be 2 up. But there's a reason that the x is minus h, the horizontal shift is minus h, and the vertical shift is actually plus k, and that's because it had originally been located over on this side. So what does this mean? If you have a number here on the inside, and it's x minus that number, that is your horizontal shift. Horizontal shift. So we can make a picture, a graph, a parabola, a line, a square root function, any kind of function. We can make it move around the graph horizontally by subtracting different values inside the parentheses there. This outside piece, this is our vertical shift, and we can make any graph move up or down depending on what we add or subtract right there. And so if you want to move a function, say, let's say 7 steps to the right. You say x minus -7 squared. So 7 steps to this is 7 steps to the left, and then 4 steps up. This means 7 steps to the left. This means 4 steps up. Now please do note that we would in fact simplify this to be plus 7. So it'd be x plus 7 squared plus 4. That's going to be a parabola, move 7 steps to the left and 4 steps up. You can move a parabola anywhere you want on the entire graph, on the entire grid, by simply adjusting what are you adding and subtracting from your x and y values.